So hello guys, good morning. Good morning all of you. Yeah, there is some noise outside. So okay na? I don't know whether it's coming to you or not. All okay? We have been using this Keil simulation, right? So simulation to test the chip level IOs. So we have tested the clock configure, clock enable disable, PCLK, no? PCLK enable disable test system already. Next, we also did GPIO testing, direction configuration, reading and writing. And yesterday we tried IOCon. So how to configure the pins for desired functionality and other features like enable, disable, pull up, enable, disable filters, enable, disable analog functionality, I2C, and all we have done, right? So in the same note, so today we shall discuss on the on-chip ADC. Okay, shall we start? So Devaki, Vijay Kumar, Venkatesh, G. Prashant, Harish Babu, Harshita, Hemant, Kalyani, Kirti, Jitendra, Lahari, Navya, Ishwari, Pranay Kumar, Prashant P, Pratima, Pravalika, Pushpanjali, Akanksha, Sai Kiran, Rohita, Pushpanjali, Sai Kumar, Shava Sankranti Bharat, Sai Lakshmi, Shreyas Acharya, Vamsidhar, and Yashashvi. Okay, so all of you got the kit, right? And I have already sent some 6 numbers. So Navya, Pratima, Pravalika, Saujanya, Inkevaru, Pushpanjali. Yeah, you received already. Okay, good. Okay, so now we are going to see so microcontroller. So NXP LPC11C24. So on chip ADC. So we'll do some test samples. దీన్ని టెస్ట్ చేద్దాం, ADC టెస్ట్ చేద్దాం ఈరోజు. Generally, what does ADC do in a simplest way? So for example, if you without breaking much of the heads, ఎక్కువ మీరు okay, I'll give you a simplest and for example ADC అనుకుందాం, think it is ADC. Okay, ADC as a black box. So what is the input of ADC? In reality, on ADC input and range. So we are going to give some voltage generally. Okay, so ADC for ADC the input is going to be voltage in the range of so for any ADC, and that is a very crucial parameter called V reference. Okay, so here we can have some V reference. Okay, 3.3 volts. Just I'm talking in general. I'm talking in general. Every ADC has got some parameter called V reference. So 3.3 అనేది ఒక specification, but I'm talking about generic ADC kind. So guys, for any ADC, and ADC అంటే generic గా చూసుకుంటే, if you look at ADC in general, I don't know why this so ADC in general, if you look at any ADC in general, so there is one parameter called V reference as so VREF. So guys, all of you with me? I don't know why this is hell, yeah. ఎందుకు ఇలా వస్తుంది? Let me try once again. So insert text box. So dot text box, okay. Wrapping. Okay, for any ADC, there is something called V reference. Okay. And input into ADC key. Able to hear me, guys? So the input is going to be so ADC యొక్క input ఏంటి? Analog voltage and okay. Analog అనేది terminology, technical terminology, but in reality wise we give voltage. Okay, so in reality we give voltage in the range of, so ఇది input అన్నమాట basically. So this is called so-called V in అంటాం దాన్ని. It's called so V in. So V in is the input voltage, and what is the output? So here we can say ADC, n bit ADC unknown. So n bit ADC, where n is the resolution. So if you think about n bit in general, because you might be working with different ADCs in future, I'm just trying to give you a very generic ADC picture here. So n bit ADC, V reference V in, and here we have something called A to D out. Output and ADC output. So D out. Okay, this is going to be A to D out. So D out. So digital out. So D out is the ADC output here. So all of you able to get my point? అంటే ఎక్కువ don't break your heads. ADC అనగానే మనకు ఉండేవి వోల్టేజ్, ఇన్పుట్ వోల్టేజ్, డిజిటల్ కౌంట్, తర్వాత V రెఫరెన్స్, n బిట్ రెజల్యూషన్, అంతే, దట్స్ ఇట్. ఓకే, అండ్ నౌ సో హియర్ వాట్ ఇస్ ద రేంజ్ వీ కెన్ గివ్? ఇన్పుట్ రేంజ్ ఏమవుతుంది? Input range 0 to, what is the input range of ADC? So we can give 0 to 0 to 8. We are 3.3, and because why you are giving 3.3? 3.3 is not generic here. 3.3 is specific only. 3.3 మాట ఎందుకు వస్తుంది మీకు? 5 volts ఉండదా? 12 ఏంటి మళ్ళీ? What is 12, Mr. Shashwi? 12 volts. So we have to say depending on the V reference of ADC. And again, you can't say, you can't fix it, kind of things. All of you got my point? అర్థమవుతుంది నా పాయింట్ మీకు? సో దాన్ని బట్టి వేరే అవుతుంది, కానీ 3.3, 5 అని కాదు బేసిక్గా. In the given circuit లో ఆ సిస్టంలో ఎంత ఉందన్నమాట డిపెండ్ అయి ఉంటుంది. వీ రిఫరెన్స్ అనేది 3.3 ఉండొచ్చు, 5 ఉండొచ్చు, 2.5 ఉండొచ్చు. ఇట్ ఆల్ డిపెండ్స్ ఆన్ what kind of circuitry and what kind of spec is there for your system. Okay, so don't generalize that. I hope you understand my point. You got my point, all of you. Okay, so VRFS బట్టి ఉంటుందన్నమాట ఓవరాల్ గా ఇన్పుట్ రేంజ్ అనేది. సో ఇట్ ఈస్ నాట్ ఆల్వేస్ 3.3 volts. So guys, am I clear? Reply. So try to respond. Good for you. Respond అయ్యి అలవాటు చేసుకుంటే మంచిది మీకు. ఎందుకంటే on the job it will help you. So if you have interacting nature, hiding nature, if you are a hiding person, then you have to pay the penalty. So you want to hide yourself or you wanted to show yourself? Tell me, you want to hide yourself or you want to show yourself? So hiding batch unte custom. Corporate world lo they can't survive if you are the person who wants to hide yourself. Okay, and what about the output range of ADC? ADC యొక్క అవుట్పుట్ రేంజ్ ఏమవుతుంది? సో డిజిటల్ కౌంట్ కదా, కౌంట్ వస్తుంది ఇక్కడ. హియర్ we can say can we say digital or count? So basically output of ADC, okay, here I mentioned properly because మళ్ళీ ఎందుకు మీకు ఆ క్లారిటీ మిస్ అయింది అనుకోండి, మళ్ళీ నాకే హెడేక్ వస్తుంది. కానీ సో the output is going to be digital count in the range of 0 to మళ్ళా 1023 అంటావు. ప్రశాంత్, నీకేమి అర్థం కదా? 1023 ఎలా వచ్చింది నీకు మళ్ళీ? I have been telling you already. చెప్తాను మళ్ళీ నువ్వు అదే అంటావు అంటే మేము ఆలోచించవా? అయ్యి అందరికంటే పెద్దవాడు ఇక్కడ ఏం ప్రశాంత్? రైట్. సో ఇప్పుడు ఏమవుతుంది ఇక్కడ? జనరిక్ గా చెప్పాలి. గో జనరిక్. యా, నేను ఆల్రెడీ కొట్టుకుంటున్నాను జనరిక్ గా చెప్పుకుందామని, నువ్వు మళ్ళీ స్పెసిఫిక్ గా చెప్పుకుంటే ఎట్లా? ఐఎమ్ గోయింగ్ ఇన్ జనరల్ 2⁻⁻1. సో కౌంట్ అనేది 0, n వాల్యూ అనేది 10 బిట్ అయిందంటే అప్పుడు మారిపోతుంది, అంతే కదా. ఇట్ ఆల్ డిపెండ్స్ ఆన్ ది స్పెసిఫిక్. ఇది జనరిక్ ఏడిసి. ఓకే, మనం ఇక్కడ కింద పెట్టుకుందాం. సో ఇది ఐఎమ్ టాకింగ్ అబౌట్ జనరిక్ ఏడిసి. జనరిక్ ఏడిసి అన్నా. నౌ ఇట్స్ ఓకే టు ఆల్ ఆఫ్ యూ. నౌ యూ గాట్ ద క్లారిటీ. ఇది జనరిక్ ఏడిసి కింద. ఇది నౌ గోయింగ్ టు స్పెసిఫిక్ ఏడిసి. The same diagram if I draw for our this one selecting objects. So ఇదే diagram ni, same diagram if I just loop it. తర్వాత if I put this కింద. So all of you know how to make use of this Windows Office. మీ అందరికి విండోస్ ఆఫీస్ వచ్చా లేదా? ఏదో కొంచెం కొద్ది గొప్ప. మనకు ఎక్కువ మాట్లాడితే అసలు కంప్యూటర్ మనం వాడం కదా. Many of you are using PC only after joining Teambits, no? Tell me how many are doing that? So you are using PC after joining Teambits only. Yes or no? So Teambits ముందు మాకేం అవసరం అండి PC కదా? మాకేం అవసరం? ఆల్రెడీ ఎవ్రీథింగ్ ఈస్ హ్యాపెనింగ్ మై మొబైల్ ఫోన్. సో మొబైల్ ఫోన్లో అయిపోతుంది అంత, మరి ల్యాప్టాప్లు ఇవన్నీ మాకెందుకు? ఓకే, ఎనీవే, ఇన్ కేస్ ఆఫ్ ది ఆన్ చిప్ ఏడిసి, ఓకే, అండ్ ఎంత VRFS ఇప్పుడు చెప్పండి, మీ VRFS ఎంత? మన స్పెసిఫిక్ ఏడిసిలో 3.3 volts VRFS తీసుకుంది. సో కాబట్టి ఇప్పుడు ఏమవుతుంది, ఇక్కడ ఇన్పుట్ విల్ బి 0 to 3.3 volts ఇన్పుట్ ఇవ్వచ్చు. ఓకే, We can give the input to 0 to 3.3 volts. N anta? What is N here in this platform? What is N? What is N? 10 bit ADC కదా. సో కాబట్టి 10 bit ADC. అప్పుడు కౌంట్ ఏమవుతుంది ఇక్కడ 2 power 10 అవుతుందా? 2 power 10 అవుతుంది. అంటే రేంజ్ ఎంత? వాట్ ఇస్ ద రేంజ్, యాక్చువల్ రేంజ్? సో దిస్ విల్ బి 0 to this is 0 to 1023. ఇప్పుడు now we can come to specific. Okay. So generic ADC it is on a specific ADC which we are having MCU on chip. So because tomorrow you might be using different MCUs, different ADCs and all, you can't always say 3.3 volts only. It all depends on, so maybe it, or maybe we don't know, 1.8 volts. It all depends on that. All of you got my point? Why I gave you two diagrams, generic ADC and specific ADC. ఈ N అనేది 8 bit అవచ్చు, 12 bit, 16 bit, 24 bit అవచ్చు. ADC can be of any size, any bit size. It can't be always 10 bit. 12 bit ADC, 24 bit ADC ఉంటాయి, 16 bit ADC ఉంటుంది. We never know what kind of ADC you are going to work in your future. Okay, so both please draw and put the picture. All of you, please draw both diagrams and take a snap and share in my WhatsApp window now. Okay, Anji ADC testing mala chuddam. Just ADC. We are going to do testing once we get some basics. Okay, maybe here one more thing we can also note down. The ADC equation out undi. I would ask now. So ADC equation would generic ADC equation. That means digital count is equal to, okay, so V in by V reference. So V in by V reference. So into 2 power n formula. This is the formula. I think ADC V in by V reference into 2 power minus 1. Generic ADC equation. Let me also give this picture to you. So all of you, please complete and report by 9:45. So how many have done as of now? One, two, three, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 only. Out of 30, still 8 members have to report. Is the n value. So resolution ఎంత వస్తుంది అంటే ఇక్కడ definitions చూస్తే మనం when we look at definitions okay so basically ADC parameters అని చెప్తున్నాము. So ADC parameters will have some discussion just to give you some extra information. Okay, so what about ADC parameters? What is V in what is V in అంటే ఏంటి? How do you define the, can you say input voltage? ADC is input voltage. And what is the digital count here? దీని ఏమంటాం మళ్ళీ 1023 అంటాడు. పారామీటర్ ని డిఫైన్ చేయమంటున్నాను బై. Not go beyond this. So guys, so V reference is the maximum voltage that we can give. We can't go, say for example, if you put VRF as say 3.3, you can't give 5 volts to ADC. You have to limit the input to, so 0 to V reference. The same thing here already given, no? This is range of input. Okay, reply. What is N? What is N? What is N here? N ఏమంటాం? N is called ADC resolution, right? Okay. So N bit and N bit. We say N bit. N bit means it's called ADC resolution. We have various reference now, N bit, and count also ADC output that. And we have something called step size. Okay, so we have step size also. Well, what is the step size? How do you define the step size? So that is minimum. So minimum voltage that minimum voltage that can be and a simple words apparently simple words. So minimum voltage that can be measured by ADC. And one ADC count at one, and meaning into count. So one count of output. Okay. ఒక count ADC output అంటే one count of ADC. And ADC count one unte, what is the voltage? That's called step size. Okay. Can we put in the formula? Can we put into the formula? That means మన ఫార్ములా ఏంటి? ఇది ఫార్ములా కదా, ఇది ఫార్ములా. So here we can say for a V reference, of 3.3 volts, okay, and n equal to 10. So V reference is 3.3 volts, so n equal to 10. And what is the step size? What is the ADC step size? So here we can measure. Now we can take this formula. We can take this formula and we can substitute those things. So we can step size. Say for example, count here one count. 1 is equal to. So V in what is V reference? So 3.3 volts. Okay, 3.3. And N, what is N value here? So 1023. So what is here? What is V in this? What is V in? What is V in here? Can you find out what is the V in from this formula equation? From this equation, what is the V in? So minimum input voltage here. ఎంత వస్తుంది? So 3.3 divided by 1023 volts, right? Equal to approximately it will be so 3.22 millivolts. Millivolts. Okay, for a variable from 3.31 and so ADC step size equal to 3.22 millivolts. This is the formula. This is the thing we should know. Okay. I think generic lo petadam idi. And here we have that for a reference of 3.3 volts or n equal to 10, ADC step size equal to 3.22 millivolts. And how it came, I already gave you that equation here. Okay. So all of you got how we got that 3.22 millivolts? Okay, also take this content. So based on this, can we test our ADC, on-chip ADC? Already we have taken this. So can we take some test samples? So ADC test samples. So we take some test samples and accordingly we'll test it in the simulation part. Okay. So how to test it? Insert one table. 3.0 ADC. So here test. Okay. So serial number. We have the serial number. Okay. So we have some serial number. We can take some 5 samples. I will see how many we can take. And this is going to be ADC input. Okay, so ADC input voltage, ADC input voltage, and ADC output. And when I say ADC output, is nothing but digital count, right? Count. So input range, input range, what we have to maintain? Input range should be 0 to range of input we have to maintain for our test. Our so 3.3 volts work మనం maintain each coach input don't go. And count ADC output digital count range ఎంత వస్తుంది? 0 to 1023 వరకు మనకు కౌంట్ వస్తుంది. ADC అవుట్పుట్ కౌంట్ ఆ విధంగా వస్తుంది. Okay, so we can take some samples. For example, 0 అయితే ఎంత వస్తుంది ఇక్కడ? Why this is? If I give 0 volts, what is my output? So 0 is ఏమవుతుంది? 0. Zero negative count. Okay, if I give, say for example, if I give say count of 10 millivolts, 10 millivolts, what is my ADC count? If I give 10 millivolts of input, what is my ADC count? What count enta? What count 10 millivolt divided by 10 millivolts divided by count ante enta? So 3.22 కదా. 3.2 మొత్తం కలుపుకుంటే ఎంత? ఇలా approximately 3 వస్తుందా? We get around 3. Count should be 3, right? Am I right? Okay, for example, if I give 100 millivolts, what is the ADC count? For 100 millivolts, what is my ADC count? So 100 millivolts divided by one count ante 3.22 millivolts. So equal to And 30, but we'll get only integer value, so it will be 30. Okay. Yeah, 31, 30, 30 was not. We'll see what is the 31 rows antarra. Okay, 31 expect chedam. Okay. And the same time, next sample, I do around 200 millivolts. So 200 millivolt divided by 3.22 millivolts equal to 62. So we'll cross check this. So 250 millivolts if I give, 250 millivolts if I give, and 250 millivolt divided by 3.22 millivolts. So how much it is? 77 approximately. Okay, almost 77. 250, 500 clip. So 500 millivolts divided by 250 millivolts equal to 155. Okay, 7 and 600 millivolts. So 600 millivolt divided by 3.22. 3.22. ఎంత ఇది 186. ఓకే, 900 millivolts వెళ్దామా? 900 millivolt divided by 3.22 millivolts. ఎంతది approximate గా 279. Again we are having 1.2 volts. Okay, 1.2 volts అంటే ఎంత? 1200 millivolts. 1200 millivolt divided by 3.22 millivolts. ఎంతది? 372 అంట, కరెక్టేనా? 372 is 9. And we have one more test sample. 1.8 volts అంటే 1800 కదా, 1800 millivolts divided by 3.22 millivolts. So equal to 559. 559 అంట count. Okay, 11. So we'll go for 2.2 volts. 2.2 volts means 2. Okay, we'll take 2.0. 2 volts. 2 volts అంటే 2000 millivolts divided by 3.22 millivolts. How much it is? 621. So 2.6 volts. So 2600 millivolt divided by 3.22 millivolts. How much it is? 807 count. Okay, 13. So 2.8 volts. 2800 divided by 3.22 millivolts. ఇదంతా 869. 869. Okay, 14. So 3 volts. So 3 volts ఎంత వస్తుంది? 3000 millivolts divided by 3.22 millivolts. ఎంత? 931. Are you sure? Last 3.3 volt పెట్టేసాం. 3.3 volts అంటే 3300 millivolts divided by 3.22 millivolts. It should be the maximum count 1023. 1023 maximum, అందుకని రాదు. అంటే ఇది అప్రాక్సిమేట్ గా పెట్టాం కదా, ఇట్ షుడ్ బి 3.222 సంథింగ్ ఏదో వస్తుంది. అప్రాక్సిమేషన్ కౌంట్ అంటే 1023 కంటే దాటదు కౌంట్ ఇక్కడ. సో దీస్ శాంపుల్స్ we need to take it. Shall we go and try this test? Okay. ఓకే. అంటే ఇప్పుడు ప్రాబ్లం ఏంటంటే మనకు సో దేర్ ఇస్ నో నీడ్ టు గో టూ మచ్ టెక్నికల్. దేర్ ఇస్ నో నీడ్. సో వాట్ ఈస్ ఫైన్. ఓకే. So what is part of when we have the hardware board, then we can discuss the application part of it. Now it is the ADC alone. So this is ADC tester. Okay. So I hope all of you are able to be in line. So before we start testing, so all of you have looked at the document, and today morning I have sent you another document. So today morning I have given you a document. We have that with you. ADC detail something, and even that also we try to open. So first we read document refresh tarvata we can see this second document. Second document is more technical, and this one is more generic, lightweight. So we have lightweight document, and then we also have technical document number 2. So once you go through that document, we also try to look into these technical aspects also. So technical aspects leaving to you how much you understand. Because you all coming from mostly EC, EEE or IT, CS background. So I think leaving to your fundamentals, how much you understand. Okay, Pravalika, can you read this content on my screen? Technical content of ADC. Pravalika, yeah.
Yes, sir. ADC input analog voltage 0 to Vs. ADC output digital count 0 to 2 to the power of n minus 1. N is ADC resolution.
That is generic information, yeah. Now we go to the specific ADC.
MCU LPC11C24 on chip ADC. There is an ADC available inside the MCU LPC11C24 with the below listed features. Successive approximation type, 10-bit resolution. We reference 3.3 volts maximum input voltage. Input range 0 to 3.3 volts. Output range 0 to 2 to the power of 10 minus 1, 0 to 1023. Step size 3.3 divided by 1024 equal to 3.22 MV. Each ADC digital output count represents 3.22 MV of input.
MV and millivolts. Millivolts, so you are calling MV. Okay.
8-channel multiplexer MUX. Up to 8 analog inputs can be given.
Okay, so we can give up to 8 inputs to this ADC. So 0 to 7, AD0 to AD7. Okay.
Can operate up to 4.0 megahertz maximum clock. Requires 11 clock pulses to convert analog input to digital count. Best conversion time 11 divided by maximum clock equal to 11 divided by 4.5 megahertz equal to 2.44 US
microseconds. Okay, this ADC can convert the digital analog digital in 2.44 microseconds. Okay, for example, if you give one sample of analog input, it takes 2.44 microseconds to convert to digital.
Recommended clock 1 megahertz.
Okay. So in the block diagram, precise. So we can give up to 8 analog inputs. We have a clock source. Okay. So again, we have 3.3 volt reference, and the ADC count also is like this. So yeah, a bit more technical now. Yeah. Continue.
More about ADC can be started either by software instruction or by hardware trigger. Each channel can be individually handled or can be grouped. By default, ADC is in power down state, requires wake up to operate. Optionally interrupts the processor CPU for each conversion. If enabled, a specific interrupt service routine ISR must be defined. ADC specific syscon and icon setup. Enable peripheral clock PCLK to ADC. Refer system config all function in syscon.c. Configure ADC pins. Refer IO config all function in icon.c. IOCon.c. ADC registers. ADC configuration or control register ADC underscore CR. ADC input channel individual registers ADC underscore DRO2 ADC underscore DR7 ADC underscore DR02 ADC underscore DR7 ADC programming list. Refer ADC.c and ADC.h. Input channel selection. Set the ADC clock to 1 megahertz. Disable ADC power down. Wake up ADC. Start ADC by software. Wait for the conversion. Stop ADC. Read 10-bit digital count.
Okay, so this information is required to know the programming part of ADC. Okay, maybe you can refer this content. And what is required now is directly I jump to the testing part. Okay, so that you also understand the overall thing. You can correlate easily. Okay, now we can choose at least one channel we can choose now. Okay, so ADC test samples on, so we can take one ADC channel, ADC input channel, AD0. We can test all these things on one channel. Okay, that is nothing but AD0. Guys, got the point? Okay, channel we can give up to 8, but we will be testing on one channel called AD0. And AD0 key, in already we have taken that IOCon setup, no? I already gave you that IOCon setup for AD0. Okay, this one we should do. IOCon చేసుకోవాలి. So I have done that yesterday already. This configuration part we have to do today. Okay. So let me show you how to do the testing. Testing part ela anedi manam cheddam. First, what we can do is ultimately, if we say we have to refer the ADC.h file. So first thing, what we can do is, so we take the base. Yeah. So take the base. All of you watching my screen? Okay. So take the base project and paste it. Now we can name it as so ADC underscore test. Okay, now. So don't mess up with previous things. So open that and go to Keil, open that project. Okay. Here we can, I told you already, IOCon a macroni we have to replace in C file. And the same thing we'll do today also. So MCU, first IOCon H file. So C file, can you open the C file and cut this line? Third line cut chesi, the full line cut and you make it move to H file. Okay, same thing. This should be done. Okay, ivocon.c నుంచి macro cut చేసి you put in h file. Yeah, and that is one thing. Okay. Next, the syscon లో clock configuration files ఉన్నాయి కదా. Maybe you can build it once. You can close this. We can reopen. Okay, so ivocon అయిపోయింది. తర్వాత main dot application main.c ఓపెన్ చేస్తాం. Syscon. So this is the function we have to call. I told you, no, it's mandatory for every project, whatever we do. No, we have to take this and then call this. So with this, what we are doing? So clock enabled, right? Clock enabled for all on-chip peripherals. So don't skip this step. If you skip this, you don't get output. Okay, దీన్ని స్కిప్ చేయొద్దు. నెక్స్ట్ ఐవోకాన్ సంబంధించి మనం ఏం చేయాలి? ఐవోకాన్ సెటప్, I think already I gave you ivocon setup also. The same thing we repeat for this. So pin number, so AD is 0 kada. AD is 0, we should take this configuration here. Okay, so pin number anta, pin number, tell me this. All of you have this configuration, no? All of you tell me this, pin number 32. తర్వాత పిన్ నేమ్ ఏంటి? వాట్ ఇస్ ద పిన్ నేమ్? పిన్ నేమ్ ఏంటి? R underscore అనుకుంటారు. R underscore, what is the pin name? R underscore PIO. అది okay. And pin function, what we prefer the pin function? Pin function we prefer is AD0. AD0 అంటే what is the number we have to give? Configuration number anta 2. Okay, and what is the pin mode? Pin mode ఏంటి మనం చెప్పేది? What is the pin mode? So pull up, pull down is pull down. Yeah, pull down enable. That means what is the configuration number? 1. Okay, very good. Next AD mode. AD mode ఏంటి? ఓకే, HYS enable అవుతుందిగా. ఓకే, సో hysteresis, so HYS enable, right? Enable, that is going to be 1. AD mode please. Analog అంటే 0 నే కదా. 0. And I2C mode లేదు దీనికి, doesn't apply. I2C mode is not applicable. Not applicable, we also put 0 there. Okay, next OD mode. Disable OD mode. We wanted to make it as regular 0. Idena total 6 items, right? 1, 2, 3, 4, 5, 6. The pin name is this one. So this configuration we should do here to operate this ADC 0. So function parent ivocon underscore set. What is the first parameter? What is the first parameter? Pin name kada. Pin name ante idi. Second parameter enti? Second parameter is pin function 2. Next pin mode. Pin mode kada. Second next pin mode 1 and HYS also 1. Analog 0, I2C 0, ఇది కూడా 0. Am I right? Okay, so it is mandatory. మనం ADCని యూజ్ చేసుకోవాలంటే ముందు రెస్పెక్టివ్ పిన్ we have to configure. First clock enable చేసుకోవాలి. Okay, before you start using any on chip, we have to make sure that the clock is enabled and then the properly configured the ivocon. Okay, Next, we can go to this hash include adc.h. So we have to include this adc.h file, and we'll find out. So we'll find out the functions are available. Okay. We'll find out the functions available. So all of you got to know what is the configuration we should do before we start using ADC. తర్వాత ఇక్కడ next thing, so the ADC function we have to pick. Okay, so ADC we have to pick. So go to ADC, and here we have two things are there. ADC config is there, and again ADC input is there. Okay, first pick the ADC config function. Okay, here we call it as. So ADC config function ఏం చేస్తుందంటే already. So this will be doing this, no? Already I gave you some points. So it does all these things. For example, clocking. So it is doing all these things. Clock is set to 1 megahertz and disable power down. So this is done by ADC configure, ADC configuration. So this function will do that. ADC clock and disable the power down. These two configuration items will be done by this ADC config function. Okay. So clock enabled, IOCon configuration, and again ADC configuration done. So these three parts. So this you can pick from your ADCH file. ADC. Okay, all of you. So ఇది మన ADC configuration part. You can refer the ADC H file and all. కావాలంటే మీరు చూసుకో, ఇక్కడ GPI అవసరం లేదు కాబట్టి we can remove this. You can put only this. Main. Yeah. Okay, now we can take one variable unsigned short, and the 10-bit count కాబట్టి we prefer to go for short is sufficient. Unsigned short, you can say A to D count. The variable name is A to D count. Okay, so ఇది ADC count ఇది ఏం లేదు. ఇక్కడ ఏం చేద్దాం మనం, what is the ADC channel we are checking? So in the real time we have to do these things. So we choose this. Okay, input channel selection చేసుకోవాలి. We have to do this. Okay, here we will be doing these things and also put these comments. So choosing the input channel. Okay, తర్వాత where we will be doing the ADC starting. So start the ADC, stop even we will do these parts, no? Whatever remaining parts we will be doing in the so choosing the input channel, ADC starting, wait for the conversion, and all these things we do in the real time. We will do in the real time part. For that, we can take this ADC count is equal to. Okay, we have the function available already. Okay, ADC get A to D count. So input number we have to give. మన input number ఏంటి ఇక్కడ? Input channel అంతా 0 కదా. So 0 channel. and that's a real-time scenario. So this is the coding part. In the configuration and initialization part, and then real time. In the real time, we have to get the ADC count continuously. Okay. So any code we share yesterday, don't worry. So this code I'll share you can test in your from your side. After I demonstrate the testing, you can also do from your side. Okay. The coding part is clear to all of you. Clock configurations, IOCON configurations, IOCON setup. ఇదేమో సిస్కాన్ కదా సిస్టమ్ కాన్ఫిగరేషన్ అంటే క్లాక్స్. దాని తర్వాత మనం ఆల్రెడీ ఐఓకాన్లో కూడా సెట్ చేసుకున్నాం. నెక్స్ట్ ఏడీసీ కాన్ఫిగర్ చేసాం. అండ్ నౌ ఇన్ ద రియల్ టైమ్ we do this process like choosing the input ADC channel, start the ADC, wait for the conversion, stop the ADC, again read the it is a continuous process. So this is going continuously in real time. Okay, so now what next? We can build, save and build. Yeah, and we can go start the debug. So debug testing part also very simple here. What we can do is you can click on the peripherals and go to the A to D converter. You can see all the ADC inputs here. Okay, the 0, 1, 2, 3, 4. We reference 3.3 already set. Nothing to worry about that. So one thing is we have to give the input here. Okay, so input ikkada we can give our samples. So already I gave you test samples, no? So these test samples we have to give here one by one. So all of you have these test samples. So before we start giving inputs, no, we have to take this variable to watch. Okay, we need to check the output, right? So for that, this variable you can add to watch one. Okay, here we have the watch one A to D count, and remove the hex and make it decimal. And we give input here. Accordingly, we check the output here. The table we need to cross check. So for that, we have to go for the full speed real-time testing. So full speed, click the full speed. So here default 0 on the 0 volts in the. So if I make it 10 volts here, for example, if I override to at the 10 million 0.001. So guys, what is 10 millivolts? Is it 0.001 or 0.1? Please confirm. 10 millivolts ante enta? Any volts? Is it 0.001 or something? 0.01, no? Okay, 0.01, no? If I give it, and then if I'm going to give this an analog inputs, so 0.01 volts. And if I give enter there, if I give enter means I'm giving this input. So enter, we have to click somewhere. Once you give the input here, you click somewhere. Can you see the count 3? One second. So guys, next sample, 100 millivolts. That means 0.1, 0.1. If you make it and click somewhere, once you update the input voltage, so you can just click mouse somewhere, it takes affected. So okay, are you able to get the count expected for 0.1 volts? It is giving 31 count. Okay, this input is going to be applied here. And then we can give 0.2, 0.2 and click, if you enter 0.2 and click the mouse somewhere, so it takes that input and it's giving 62 volt count. Count is 62. Did you observe that input and output to this one, all of you? So open that A to D converter window from the peripherals and you can try to give the inputs here. Okay, give the input here and click the mouse somewhere. Once you give the input, for example, if you give 0.5, 0.5, and you have to click the mouse somewhere, maybe here you can click, it takes that input and it gives the count as 155. And any problem? Same thing, in the debug window, peripherals, A to D converter. And here the input we have to give. Am I clear, guys? So can you work on this? ADC test application, I'll try to give this to you. One second, I'll try to minimize this. Now I can take it nicely. Okay.